So today we talk about ozonolysis reaction of alkenes and benzene. So this topic is generally covered in IIT as well as NEET. Definitely there would be at least one question from ozonolysis reactions, right? So we'll see some basic level to higher level ozonolysis of alkenes and benzene derivatives. So what is it exactly here? I'll take one I'll take one alkene here, that CH2 double bond CH2, it is an ethene. When reacts with O3, so it forms an ozonide where the double bonds of alkene disappear and these oxygens are connected to carbons in this fashion, right? So this is what we call it as ozonide of ethene is formed. The very first reaction happens here. Just ozone goes and adds on the double bond and forms a ozonide. This ozonide undergoes splitting in presence of zinc and water, where this oxygen is given to water and this guy becomes one aldehyde, this becomes another aldehyde. That means I will be getting 2 moles of CH2O and H2O2 is formed in this reaction. So this is actually the ozonolysis reaction of alkene. In any alkene, the condition is only one. You have to break the double bond. One oxygen should be added towards one CH2 and another CH2. It's a simple reaction, and just you can write the product if you are able to do it. So for solving this IIT as well as NEET exams, we are not going to write all these kind of reactions, but we directly try to predict the answer. We'll see few examples here. So the first one is I got CH3 CH double bond CH and CH3. So this is the 2-butene when ozonized in presence of zinc. What will happen? What you have to do? You have to do only one thing. You have to break this oxygen, break this double bond. You add one oxygen here, another here. That's it, nothing else. So the final product के लिए मुझे इसको यहाँ से तोड़ना होगा, इधर एक ऑक्सीजन अटैच करना है, इधर एक ऑक्सीजन अटैच कर देना है. Just you have to write these two products. The first product is going to be CH3CHO, and the next product is also same. 2 moles of CH3CHO is formed, and one of the oxygen of O3 will be given to water, where water is converted to H2O2 में convert होता है. Just you break this bond, add the oxygens, you will get this product. And condition ये है, अगर डबल बॉन्डेड कार्बन्स के पास हाइड्रोजन है जैसा वैसा, यू विल ऑब्टेन ऑल्डिहाइड. अगर हाइड्रोजन नहीं है उसके पास, यू ऑब्टेन द कीटोन. फॉर एग्जांपल CH3 C डबल बॉन्ड CH3, देख लीजिए इसके पास कोई हाइड्रोजन नहीं है. किसके पास? द carbon having double bond has got no hydrogen, not here, not here. So therefore you split this way, you add one oxygen here, another oxygen here. So the product is going to be CH3 and it gives you C double bond O. This is acetone, and this is also another mole of acetone is formed, and the byproduct is of course H2O2 is formed. In this way we solve all the question. Just you split the double bond, just you add the oxygens on both sides, then you get the product. Split the double bond, add the oxygens on both sides, and you will get the product. Simple. So we'll move on. How can we solve few more examples? I'll take one more example. Like, so I have got CH3, both are connected to one carbon. Here this guy has connected to CH3 and hydrogen. तो इसका प्रोडक्ट के लिए व्हाट यू नीड टू डू, you split this bond, add one oxygen here, another oxygen here. That's it. The product is gonna be the CH3 which are connected to the same carbon has got one oxygen here. This is the oxygen what we have got here, plus this is going to be CH3COH. So that is CH3 C double bond O and H. So these are the two products formed here. So this is the oxygen which is from O3 and this is the oxygen from O3. Two oxygens are obtained from the O3. Of course, we have got the side product, that is H2O2. We always do it in the presence of zinc. Now we have to understand the job of the zinc. If we use the zinc, one of the hydrogen is given to H2O to convert H2O2, where we end up with the ketone as well as aldehyde. If zinc is absent, we have to write the carboxylic acid product lignin. Right, we'll see one more example here. So I got CH3 hydrogen which are connected to same carbon, and here we have PH and CH3. The procedure is again the same. You split this bond, इधर एक ऑक्सीजन अटैच कर दीजिए. The first product is going to be CH3 C double bond OH, an aldehyde is formed, aldehyde plus PH CO CH3. So that is PH CO CH3 is formed. Acetophenone and aldehyde. This is a ketone formed here, and aldehyde is also formed here. Just you need to split it, and just you need to add the oxygens on both sides. We'll take one more example here. Let's say this is one compound here, यहाँ double bond है. So for this what you need to do, you split this bond from here. We know that here we have CH2, here we have CH, here it is CH2, here it is we have CH3. So we have got an aldehyde with 3 carbons, CHO, and another aldehyde with only 1 carbon, that is CH2O. Acetaldehyde or formaldehyde are the products here. Simple products you can write in any fashion, the complex is going to be similar. So I'll take one more example here. What I'll take here, I'll take cyclohexene लिया मैं, cyclohexene with the double bond. तो इनका ओजोनालिसिस कर रहा हूँ O3 in presence of zinc and water. Again you need to do break this bond. यहाँ से bond को तोड़ना है, इधर O attach करना है, इधर O attach करना है. So that is going to be in this way. Here you will get one CHO, here we get one CHO. This is hexane diol is formed here. So already we know that we have a carbon and hydrogen here where double bonded carbons are present. Just you need to add the hydrogens to this. Let's say I get one more compound here, cyclohexadiene लिया हूँ मैंने. तो इसका भी हाइड्रोलिसिस करने से यहाँ डाई ओजोनोलिसिस हो जाएगा. 2 moles of ozone and the zinc plus water के साथ रिएक्शन होगा. Again you need to break this bond and bond. Here you need to add oxygens on all the sides. So that means if I break this here, 1 2 3 carbons वाले compound एक बनेगा, ये वाला 3 वाला भी एक compound मिल जाएगा. मुझे ऐसे मिलेगा CH2 के साथ एक CHO प्रोपेन डायल एक मिलेगा, and दूसरा भी प्रोपेन डायल. 2 moles of it is being formed here when I take cyclohexadiene. Let's say I'll take cyclohexadiene connected with CH3s. Here it is one CH3, here it is another CH3. Here I put only one CH3. Let's not forget the hydrogen is present here. What would be the product of ozonolysis here in presence of the zinc? Again we have to do the same thing. You break this bond, and add one oxygen here, here. So here and here. That means, so this portion is going to be one molecule and the other one is going to be the other molecule. So the first molecule I'm going to write here, the first molecule I start with the CH3 followed by CO followed by CH2 followed by CO followed by CH3. This is the first product formed here, and apart from this I get this product also. So this product I'll start from here, that is CH3 followed by CO followed by CH2. At the end I got the aldehyde group because we have hydrogen here. So here we got the diketone, acetyl acetone is formed. So here, so 3-keto aldehyde is also formed here. Just you cut with the double bond and attach the oxygens on both the sides, you will get the products here, right? So we'll see few more examples. Yeah, let's take the most famous example, that is benzene. इसी के ऊपर क्वेश्चन 2012 में मेंस में पूछा था. दिस इज द बेंजीन. सो बेंजीन का ओजोनालिसिस करना है. 3 moles ऑफ ओजोन से रिएक्ट करेगा इन प्रेजेंस ऑफ जिंक. Obviously it has got 3 double bonds. These are going to split down. Here the oxygens are going to attach on those things. That means the 2 carbons are going to stay connected with each other. So the products are going to be CHO and CHO. So these are 3 moles of it is being formed here, right? So if I want to write the product in the same fashion, so this is one compound and this is one compound and this is one compound. Here is CHO, 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 here is CHO. Actually if you check the structure of benzene with this, यहाँ डबल बॉन्ड था, यहाँ डबल बॉन्ड था, यहाँ डबल बॉन्ड था. मैं डबल बॉन्ड को कट करके यहाँ पर क्या दे दिया हूँ, डबल ऑक्सीजन अटैच किया है. ये डबल बॉन्ड काट के मैंने दोनों को ऑक्सीजन दिया हूँ. यहाँ देखो, ये डबल बॉन्ड काट के ये दोनों को ऑक्सीजन दिया हूँ, देख लीजिए. एंड ये डबल बॉन्ड काट के मैंने ये दोनों को ऑक्सीजन्स अटैच किया. जस्ट यू कट इट थ्रू द डबल बॉन्ड एंड अटैच द ऑक्सीजन्स टू गेट द प्रोडक्ट्स हियर, right? So what if benzene is substituted by some other alkyl groups like this? Let's say here I have got CH3, here I got CH3, and here I got CH3. So since we have 3 double bonds, tri-ozonalysis takes place in presence of zinc and water. Again we need to split the same thing here. So what we need to do? So we have to break this here and here and here. So if that is the case, so this compound with CH3, CO and CHO would be one compound, and CH3, CO, CHO would be another compound. CH3, CO, CHO would be another compound. So the product is going to be CH3, CO and CHO. So this is one product, this is another product, this is another product. We get 3 moles of ketoaldehyde is formed. Of course byproducts are formed here. H2, O2 are the byproducts formed here. Let us see one more example here. I'll take benzene, substituted benzenylaramide. So this is the benzene. So here I got CH3, here I got CH3, here I got CH3. So again we need to do the same thing. You have to split this double bond को काटो, oxygens attach करो, and make sure you have carbons and hydrogens along with this. You don't break that rule. So the first compound is going to be CH3, CO, CHO. This is one product. CH3, CO, CHO is one product. This is CH3, CO, CHO. 2 moles मिल गए. This is CH3, CO and CH3. So total 2 moles of it are being formed here. 2 moles of it are formed in this reaction, right? So we'll move on. We'll take one more example like this. So I take the same example, but I'll change the position of the double bonds. CH3, CH3, CH3. So here there is the double bond. No, I'll keep one more CH3 here. Double bond is here, and here and here, right? I got the same position of the double bonds, so double bond should be changed, again the same product will be obtained, right? So we'll see few more examples. I got cyclopentene, so connected with CH3s on these two carbons. So what are the products expected here? आपको यहाँ से तोड़ना होगा, so आपका जो प्रोडक्ट मिलेगा, जो साइक्लिक फॉर्म टूट कर आपको ओपन चेन वाला आल्डिहाइड अल्डो कीटोन मिल जाएंगे. So it's going to be, I'll start with this. See here, CH3, which is of course connected to CO, again CH3 on the top side, so it's going to be the same direction, and here it is CHO. This is the product formed here. So you can observe from this that I have deleted, यहाँ क्या हुआ करते थे, डबल बॉन्ड होता था, डबल बॉन्ड को मैंने कट किया है, इधर एक ऑक्सीजन इधर एक ऑक्सीजन अटैच किया है. सिंस दिस कार्बन हैज़ ऑलरेडी वन हाइड्रोजन, दैट्स वाई ये आल्डिहाइड ग्रुप बन गया, एंड दिस हैज़ बिकम, दिस इज ऑलरेडी ए कीटोन ग्रुप. सो दिस इज हाउ यू राइट द प्रोडक्ट. अगर आपका क्वेश्चन रिवर्स पूछे, व्हाट इफ, अगर किसका ओजोनालिसिस से एक्स दिया है, यहाँ एक्स का ओजोनालिसिस करने से ये मिल गया आपको, सो व्हाट इज द स्ट्रक्चर ऑफ एक्स बोल के भी पूछ सकता है. इन दैट केस व्हाट यू नीड टू डू, you have to connect these two carbons with a double bond and just you delete these oxygens, then your product is the same, the product would be the same, right? So this is how the question is asked. The question asked was 2 methyl. So one more example भी देखेंगे. मैंने यहाँ CH3 अटैच किया है, यहाँ भी CH3 अटैच किया है, यहाँ डबल बॉन्ड अटैच किया है मैंने. बोलिए व्हाट इज़ द प्रोडक्ट एक्सपेक्टेड हियर. सो आपको यहाँ से तोड़ना होगा, यू नीड टू कट दिस फ्रॉम हियर, यू नीड टू ऐड वन ऑक्सीजन हियर, वन ऑक्सीजन हियर. सो आई विल राइट द प्रोडक्ट हियर, CH3, C, दिस गोस हियर. यहाँ पर क्या है, अब CHO आ गए, तो यहाँ पर आपको CH3 तो ऊपर बैठा है, यहाँ CHO एज इट इज़ है. यहाँ क्वेश्चन उल्टा भी पूछ सकता है, देख लीजिए, यहाँ Y का ओजोनालिसिस करने से ये मिल गए. व्हाट इज़ द स्ट्रक्चर ऑफ Y? Y के लिए क्या करना है आपको, ये ऑक्सीजन्स डिलीट कर देना है, उसके जगह यू नीड टू कनेक्ट द डबल बॉन्ड्स. दैट्स व्हाई यू कैन राइट एनी प्रोडक्ट गिवन टू यू, any product given to you, you can write the structure. Now we take up some questions which are asked previous year. So this is the question asked in the previous year, JEE Mains 2022 में पूछे सो क्वेश्चन है. The question is, which among the following pairs of structures will give different products on ozonolysis? Consider the double bond in the reaction structures are rigid and non-delocalized. So we have given 4 options, we have to select which one is different one. So it means what, the first one gives one kind of product, second one gives different types of products. That's we have to find it out. So let's do the calculation here. So for the first one I have to cut these bonds like this. So 1 2 3, so I will get one CH3 CO CHO, this is CH3 CO CHO, 2 moles मिल गए, and this is going to be glyoxal. So I have got 1 mole of glyoxal and 2 moles of 2 keto propanol. So let's do this also. So for this, so here is one glyoxal, CHO and CHO, 1 mole of glyoxal. This is both are same kind of ketones, CH3 CO CHO. So in first option we are getting only same kind of products. This is not the answer. We'll go for this. तो इसका ओजोनोलिसिस करने से you need to break these bonds 1 2 3 1 2 3 and glyoxal. इसमें भी आपको वही products मिल रहे. So let's do this here. So ऐसे break करने से 1 2 3 1 2 3, तो इसका भी same products are being formed. But when it comes to this compound, we break this guys. So ऐसा break करने से, so this is glyoxal, CHO and CHO is formed. right? This is diketone is being formed here. Check here. This is going to be a diketone which gives CH3CO CO CH3. This is the diketone, and this is also glyoxal. 2 moles of glyoxal and 1 diketone is formed here. But when this is subjected to the same process, we'll get what? 1, 2, 3. So it's going to be CH3CO CHO, again CH3CO CHO, 2 moles of it and 1 mole of glyoxal is formed. So up to now we have got all the aldehydes, but इसमें एक डाइकीटोन मिल गए. So probably answer could be ये होना चाहिए. So this is our answer. तो इसमें भी वही प्रोडक्ट्स मिल रहे, तीनों भी वही प्रोडक्ट्स इसमें भी मिल रहे. So answer for this question is the same thing. Right? Answer is C. So if you do it patiently, you can answer the question properly. We'll move on to the next question. The question is about A and B respectively in the reaction. So A reacts with ozone and produces ethane 1,2-dicarbaldehyde and glyoxal. B reacts with ozone and produces 3-oxohexanol. So we have to state what would be the products of A and B. अगर आपका वीडियो आप पहले से सीधा देख रहे तो यू कैन डू इट. सो इट इज ईथेन ऑक्सॉल डाइकार्बाल्डिहाइड. देख लीजिए, ईथेन हैज़ 2 कार्बन्स एंड इसमें डाइकार्बाल्डिहाइड है. सो दैट मीन्स इट शुड बी ब्यूटेन डाइऑल होना चाहिए, CHO एंड CHO, right? And glyoxal must be CHO and CHO होना चाहिए. So that means total carbons are 1, 2, 3, 4, 5, 6 carbons है. So total carbons are 6 and one of them is glyoxal. glyoxal के लिए यहाँ एक डबल बॉन्ड होना ज़रूरी है और यहाँ एक डबल बॉन्ड होना ज़रूरी है. So it should be 1, 2, 3, 4, 5, 6. cyclohexane का 1,5 डाइहीन होना चाहिए. साइक्लोहेक्सेन 1,5 डाइहीन होना चाहिए. या दिस इज वन ऑफ द ऑप्शंस. 1, 2, 3 ऐसा भी ले सकते हैं. 1, 2, 3. सो इट कुड बी 1, 2, 1, 3 भी होगा. 1, 3 भी हो सकता है. सो हियर वी हैव 1, 3 डाइहीन, हियर वी हैव 1, 3 डाइहीन. आवर ऑप्शन शुड बी वन ऑफ द B और D में से एक होना चाहिए. We have to figure out this also. So we have to write the structure of this guy. 5-oxohexanol. Hexanol has got 6 carbons. So 1, 2, 3, 4. So this is hexanol. 1, 2, 3, 4, 5, 6. 6 carbons are in this way. So 5th carbon के पास oxo है. So this is got oxo. That means I have to connect first carbon with this double bond and यहाँ एक मिथाइल ग्रुप होना चाहिए. That means it should be एक पेंटागन होना चाहिए. I number the carbons 1, 2, 3 and 4, 5, right? So 1 and 5 are connected and इसके पास एक मिथाइल ग्रुप होना ज़रूरी है. So यहाँ डबल बॉन्ड होगा तो इसको तोड़ने से यहाँ अल्डिहाइड मिलेगा, यहाँ कीटोन मिलेगा. दैट वुड बी 5th कार्बन, राइट? सो इट शुड बी मिथाइल साइक्लोहेक्सीन या साइक्लोपेंटीन, मिथाइल साइक्लोपेंटीन. सो आवर आंसर इज डी. सो इन ऑप्शंस, सो वी हैव बोथ द ऑप्शंस. साइक्लोहेक्सेन इसमें भी करेक्ट है, लेकिन साइक्लोपेंटीन से आपको ये नहीं मिलेगा. 5-oxohexanol इज नॉट द प्रोडक्ट हियर. बट व्हेन you take up cyclohexane 1,3-diene and methyl cyclopentane, the products are same. So products are same. We'll figure it out again. cyclohexane 1,3-diene, cyclohexane ये है. So ये 1, 3, 1, 2, 3, 4. तो यहाँ से तोड़ने से ये glyoxal मिल गए, पहले वाला प्रोडक्ट. एंड नेक्स्ट 1, 2, 3, 4 कार्बन वाले कार्बाल्डिहाइड मिल गए. नेक्स्ट मिथाइल साइक्लोपेंटीन. मिथाइल साइक्लोपेंटेन, दिस इज मिथाइल ग्रुप, यहाँ डबल बॉन्ड होना है, यहाँ से काटने से आपको ये ऑल्डिहाइड ग्रुप बन गए, ये कीटोन बन गए. सो ये फिफ्थ पोजीशन में ऑक्सो है. सो और आंसर इज डी है. राइट. विल टेक अप फ्यू मोर क्वेश्चंस हियर. Right. So here draw the structure reactants in the ozonolysis here. So here what you have to do, you have to think about reversely. So here this is one oxygen, here this is one oxygen. Mostly you have to connect these two carbons by a double bond. So for that we think about the ring and then we'll figure it out easily. So for that what I'll do, I'll number the carbons 1 2 3 4 5 6 carbons है. So what I'll do, I draw a hexagon. हेक्सागन में ये दोनों के बीच में मैंने डबल बॉन्ड रख दिया है. इसको 1 नंबर दिया हूँ, इसको 6 नंबर दिया हूँ. राइट. तो ये 5 होगा. 5 के पास एक मिथाइल दिख रहा है मुझे. राइट. 5 हैज़ गॉट वन मिथाइल ग्रुप and 1 has got another methyl group over here. So there should be one methyl group here. अगर इसको यहाँ से तोड़ देंगे, so this will be CHO. 6th कार्बन के पास CHO दिख रहा है मैंने, and again it has the ketone group. So answer for this question is cyclohexene, मिथाइल साइक्लोहेक्सीन होना चाहिए. द टू फर्स्ट मिथाइल साइक्लोहेक्सीन होगा. So this is our answer for this question. We'll move to the next question here. Here we have two cyclohexane rings. One of them has got the double bond. Here it is. करना क्या है, इसको आपको बीच में से तोड़ना है. इधर एक ऑक्सीजन अटैच कर देना है. So what I'm gonna do is here. So this is the first ring structure. This is the second ring structure. नाउ यहाँ पर आपको एक कार्बन अटैच करना है. कार्बन के साथ ऑक्सीजन, यहाँ भी एक कार्बन के साथ ऑक्सीजन, यहाँ मिथाइल ग्रुप और यहाँ मिथाइल ग्रुप कनेक्ट किया है, तो आपको ये प्रोडक्ट मिल जाएगा. सो इट्स ए डाई कीटोन आपको प्रोडक्ट में मिल गए. जिंक है इसलिए वी आर डूइंग दिस. राइट. नेक्स्ट कंपाउंड देख लीजिए. एक ऑक्टाडाइन दिया हुआ है, तो इसको यहाँ से तोड़ना है, यहाँ से तोड़ना है आपको. Just you need to break those bonds to get the final product. Here इसको यहाँ से तोड़ा है, यहाँ से तोड़ा है. Just you count the carbons. 1 2 3 4 5 6 7 8. So that means the product of this compound is going to be, so ethane dicarbaldehydes are 2 are formed in this reaction. Hope you can understand it. Right. So here are 2 more questions. So again you have to break this double bond. Then here also you have to break this bond. So you can do the work here. So it's gonna be cyclohexane. So having connected to double bonded O and CH3, this is the first compound, and second compound is also same. 2 moles of it is being formed. So in this reaction we have already seen one of the product is acetone and another product is going to be CHO with 2 carbons, CH3 and CH2. So this is how you can balance and solve the questions of ozonalysis. Right. Thank you.